All right, everyone. Thanks for watching these again. This is the second lesson. Just to reiterate what I like to intro with, we can pretty much do anything we want in Excel. If you look it up, Google's a great reference. This is just some of the tools that should help you at your job here. This lesson is dedicated to the if function. We covered it at the end of the last lesson, but it's important enough that we dedicated this entire lesson to the if function. As you remember, the basic structure of the function is if and then a logic test, which would either be true or false, and then the output if that logic test is true or false. So this is the second lesson. You can see this statement says if F5, which is this cell, is equal to F6, which is this cell. If they're equal, it means you've attended all lessons. Great job. But if not, if they're not equal, maybe you need to try harder. So let's say you've come to this first class. Maybe you didn't need the other class, but maybe it couldn't hurt, so you should try harder. So I'm going to set those equal to each other. Now I want you to, as a warm-up, write an if statement to see if the number of new employees is equal to the number of orientations completed. For true, your statement should return yes. For false, your statement should return no. So how do we write this? We say if the number of new employees is equal to the number of orientations completed, then yes. If that's not true, no. So it's a basic if with a true logic test of equality, then yes or no. You can see if you've done 10 orientations for 10 new employees, the answer is yes. Now, we are going to walk through basic Excel if test criteria. So these are logical tests. This is just if a cell equals certain tasks. So you can say, in this example, we say, does the cell in E14 equal the word fun? If it does, then the output is yes, and if not, no. So you can see the logic test here is E4 equals fun. If it's true, yes, with an exclamation mark. If it's false, no. So if I change this to be the word gratitude, that does not equal fun. You can see my logical test result is false. So if I change this back to fun, now if it's an exact match for text, so if I say this is funny, it's also not going to be true. It's only a perfect match. It's not a string match. It has to be fun. You can do it whether a cell equals a number. So here we say, does this cell equal the number 4? Yes, it's true. If I put a 3 in here, it's no longer true. A cell equals another cell, so I can say, as we did above, does this cell here equal this cell here? So we know 10 doesn't equal 4. The result of that is no. So here we're saying, does E17 equal the word fun again? No. It says learning. I'm still learning. I am having fun though. I'm going to switch that, and now this is true. Does not equal, so I can say, does this word not equal? So this first test we've done extensively is the equals test. This is how you do does not equal. It's a greater than and a less than symbol. So it's the two put together. So you'd say, if E18 is not the word fun, then give me yes, otherwise give me no. So learning is not the word fun, but if I change this to the word fun, this is now false because I'm looking to see if it's not equal to fun, and it is. So if I change it back to learning, you can see. So I want you to play with these. This is does not equal to greater than greater than or equal to, less than or equal to will only work with numbers. So does not equal to and equal to does work with text and string matches, but you can't, words are not greater than other words in themselves. You could try to debate that, but for the purposes of Excel, greater than or equal to, less than or equal to is all going to be numeric relativity. So in this case, do we say is E19 greater than 4? The answer is no, because it's the number 4. Is it greater than or equal to 4? Yes, it is. Is it less than 4? No. Is it less than or equal to 4? Yes, it is. So that is just cells greater than or equal to, does not equal and equal. You can also do tests for, instead of comparing things, just asking Excel, is this a number? So I can say, and I'll write it up here, and I can say, if I say is number, and I show this value, which we know 10 is a number, it's going to say true. So that is the way the true-false test it works. If I say equals is number, and I ask if orientation is completed as a number, no, it's not. So it's just a test whether it's a number or not. It doesn't tell you anything about that number. So we can say, is this cell a number? Yes, it is, so that's true. If I make it the letter A, it's no longer a number. It's false and no. Is text is kind of the opposite of is number. It says, does this have a numeric value? Or is this text and not have a numeric value? So if I put a number in here, it does not consider it text. It thinks of it as a number. But if I say the word fun in here, yes, fun is text. That's true. Is blank is also just if there's nothing there. So I can say, hey, there was no result, or if this is totally blank, then that's true. So if I just put anything in here, whether it's a number or a letter or a formula, it's not blank anymore. But if I delete what's in there, it is. Is NA? This only refers to if the output is an NA. So I can say, you know, if that is an NA, I can test for the NA. So sometimes if you look for a cell that doesn't exist, you'll get an NA. Sometimes you'll get other errors, which is why we tend to use is error, because is error is kind of a catch-all. So you could do is NA, but is error also covers NAs. So let's say I'm trying to divide by 0. So here I say let's do 10. This one up here, let's say this one divided by this. We know that's an error. And this test here is saying if this is an error in F28, then that means it's true, yes. But so if I say 10 divided by 10, that number is 1. 1 is not an error, and this is now false. So is error is going to be useful if you have several errors and you want to do something when that error occurs. If error is a specialized test that kind of incorporates if and is error, it's something that was added, I don't know, 10 years ago. It didn't always exist. But the idea is to provide the error with an alternative. So I can say, you know, if the output of this is an error, what do I do instead? So if it's not an error, it'll just give you that output. Refer to this cell. So right now it's saying 10 divided by 5. Okay, 10 divided by 5 is 2. So that is not an error, it's a real number. So if I say if error 10 divided by 5, or if error this cell, and it's not an error, it'll just give me the output. So you can see my output here is 2. If I make this a 5, my output is 1, because those are not errors. It is not seeking an alternative. Now, if I change this to a 0 and I try to divide 5 by 0, instead of giving you divided by 0, it says, yes, this is an error, and so because it's an error, I want to use the alternative, which the alternative in this case is a no exclamation mark. So you can see that, yes, we do get an error from this, and that alternative is no. You could write this the same way with if is error, where you provide the true as the result and the false as the no, but this kind of is a more compact way to do if is error. Now we've talked about the standard logic tests. One thing that's important to note is the multiple criteria tests. The ones that we use are and or. For an and test to be true, all subtests within the and it can be in as many as you want, have to be true for it to be true. For the or, if any of the tests within the or statement are true, then the whole thing is considered to be true. So to highlight this, we have 2 cell references. They both say fun and learning. I want to test if the first one says fun and the second one says excel. The third test is, are the 2 not equal to each other? So in this case, the first one, yes, is fun, but the second one does not equal to excel. The third test is true. Fun and learning are not the same word. So in this case, for the true test, for and, we have a true, a false, and a true. And because we failed the is this word equal to excel, then the whole thing is considered false. We're using the no for the false output. Now in this case, for the or test, we say, is E36 equal to 4, or is F36 equal to excel, or are they not equal to each other? So you can see logically the first one is true because fun equals fun, but excel does not equal learning, so you have a false here. And then yes, they are not equal to each other. So that passes that one too. So the 2 trues is enough. We only need 1. It makes the output true. So let's make this word excel. You can see now all 3 tests are true, so the final output is the true output. In this case, if we say, let's make this excel, you can see we have 2 false tests, but still, because they do not equal each other, the whole thing is considered to be true because it passes that. Now let's make them both learning. And now none of these are true. None of the or statements are true, so it is the false test. This does not equal the word fun. This does not equal the word excel, and they are equal to each other because they are the same word. So we've covered the single if tests, but in your true and false, you can also do additional if tests. And nested ifs is a very powerful way to kind of write a formula that works for multiple combinations. And if you have a single if statement, you can get 2 results, the true and the false. But if you use another if, you get another one added. So if you have 3 outcomes, you would need 2 ifs, but you could have 4 outcomes and have a third if. It can go as far as you want. So here's an example of nested ifs where we use multiple if statements together to achieve kind of a result for multiple outcomes. So in this case, I want to use 2 people's birthdays. And I want this to say, if Alton is older than Andrew, state next to Alton, I'm older. If Alton is younger than Andrew, state I'm younger. And if they're the same age, state we're the same age. So we're going to do it for both of them. So let's do it for Andrew first. We're going to say if, and the first test is going to be, are the dates the same day? So if those 2 are equal to each other, then that means we're the same age. Okay, but if they're not the same age, I don't know if he's older or younger. So let's say if his birthday is less than Alton's birthday, then that means I'm older because the date value is lower and that's an earlier date. And now we know that he's not, if they're not the same age, it's already false to that. And you're false to I'm older, we do know as a default the last one left is that I'm younger. So it wanted me to have two parentheses there. Let's write it for Alton too. So if this is the same as this, then say we're the same age. If this is greater than, and it doesn't have to be less than or greater than, I'm switching it, but you're true or false, the order of those things doesn't matter. So if this one's greater than the other one, you can say I'm younger. Otherwise, I'm older. Okay, so this looks right. Right now, Andrew's birthday is before Alton's. It's in 1984, and his is 1985. So he'd be younger. Let's say Andrew's birthday was in 1986. They both switch. Now, Andrew's younger and Alton's older. Let's make this the same day. And they're the same age. So that is, there are three combinations and you have two if statements. You have one for the first one and then one for the other two. This is a harder example where we say, okay, if Andrew likes the same sport as Alton and Bowie, we all like the same sport. So if all three are the same, they're all the same. If Andrew only likes the same sport as Alton, then say I like the same sport as Alton. If Andrew only likes the same sport as Bowie, say I like the same sport as Bowie. Otherwise, if Andrew's sport is unique and Bowie and Alton like the same sport, say no one likes the same sport as me. Otherwise, if everyone's sports are unique, state, and this is not quite big enough, say none of us like the same sport. So Andrew can either match both Alton and Bowie, he can match one of them individually, or they can all be different. Or Andrew can match none of them, and Alton and Bowie can match together, and Andrew feels left out. So we have 1, 2, 3, 4, 5 results. So we're going to need 4 ifs. So let's start with the first combination and just say, okay, if this, okay, it has to be an and because I'm going to test if he's the same as both of them. So if and this equals this, and the next one is this equals this. I realize this is a step up in difficulty. This is kind of the hardest it gets for these nested ifs. So there's 2 tests for the and. If both of them are true, then in this case, we all like the same sport. If you can do this, you're doing great. Okay, so now let's say if I have the same, if I like the same sport as Alton, so if B50 equals B51, comma, I like the same sport as Alton. Okay, if they're not equal, let's find out. Let's say, okay, well, if Andrews is the same sport as Bowie's, comma, I like the same sport as Bowie. Okay, if that's not true, we already know it goes in order left to right. So the first test, it'll only get to the false if the first test fails. So in the first test, I said, does Andrew match Alton's and Bowie's? If that is true, you don't have to worry about it finding Andrew matching Alton later. So there's an order, it reads left to right, so that's how we can kind of carve out each combination by eliminating the ones before it. So what we have left is Andrew has the same sport as nobody, and Alton and Bowie's match, and then all three are different. So now I want to say if, and this is and I'll say Andrews does not equal Alton's, but, oh, and Alton's does equal Bowie's. So if that and is true, then what does that mean? That means the two of them, no one likes the same sport as me. And then if all these tests are false, it means each person has a unique sport. And I say none of us like the same sport. And then I close all these ifs, 3, 4. Remember we mentioned we'd have 4 ifs? Okay, so right now Alton and Bowie's match. Andrew's favorite sport is Frisbee. Alton and Bowie have the same sport. So let's say Alton's favorite sport is soccer. It says none of us like the same sport. Now let's say this is Frisbee and this is Frisbee. That says we all like the same sport. And if Alton likes swimming, but Bowie likes Frisbee, it says I like the same sport as Bowie. And if I say Frisbee here and Bowie is swimming, then I like the same sport as Alton. So you can. Okay, and once you're done writing it for Andrew, I want you to write the same for Alton and Bowie, comparing it to the other two. And then when you've done that, you can do the assignment. So each page after this has exercises to complete. We'll walk through them really quick, but if you have questions or trouble, just let us know. Okay, in this case, what I want you to do is just separate the logic test and write what you think is the expected result. So this one, it says, is reference 1 greater than reference 2? So this will be, is B3 greater than C3? And I expect that to be true because 10 is greater than 4. So go down through these exercises, see if you can complete them. This is multiple logic tests. In this case, you see we're using ands and ors. In this case, it says, is reference 1 equal to reference 2, or is reference 1 equal to reference 3? And in this case, we're saying, is fun equal to learning, or is fun equal to excel? We expect neither of those is true, so your or statement is false. In this case, we say reference 1 is less than reference 2, and reference 1 is greater than or equal to reference 3. Write out the logic test and write the expected result. Here we have logic if tests. In the top section, we have a true output that we want and a false output, and the cell references. So I want you to write the whole if function with using the cell references for the test, and then your true output or false output that we ask for. So in this case, it says if reference 1 is greater than reference 2. So I'm going to say if reference 1 is greater than reference 2. I don't expect that to be true, but if it is true, the true output that I want is reference 1 minus reference 2. So I would want this minus this. And if it's false, I want reference 2 minus reference 1. This is a backwards way to do the absolute value of something. Of the subtraction to make sure it's always the greater number subtracting. So do these. If you're right, it'll switch to correct. Here is an example where we say we want to determine how many employees in the list are still active. Write an if statement using is blank operator to write the word active next to all employees who are currently employed at the firm. So here we have hire dates and termination dates. We say if the termination date is blank, that means they must be active. So write an if statement to say if they're active or not. And if they are, write active, otherwise it's blank. So I want you to write a function here that works as you paste it down. Here we have a real world example. It says get an average price for a ticker here over the past trading week, but because Monday was a holiday and we're not getting shares or market value for that day, the calculated average price gives us an error. Use what you know to give blank instead of this divided by 0 error for this error. The average price is going to be the net amount divided by the shares. So this is just writing a statement that highlights the total average price. You don't have to do anything down here, just in the highlighted columns. So this matches the format of the other multiple logic ones with the ors and the ands with ifs. And then this is a little bit more difficult nested if test. So you're going to have to write a statement that works here in the real world example to deal with ticker change. So as you work through this, if you have questions, let us know, but good luck.